So I'm Dan Barker. I work for a company called DST Systems. Show of hands, anybody know who that is, what they do? No? Okay. For a long time, we tried to remain secret. We have like 75, 80% of all mutual fund data. So if you have a mutual fund, we probably have your data in our system. So we were a big target for, if that data disappears, then the economy is in a really bad place. So we started to come out a little bit more, and we've started buying some healthcare companies as well because the financial regulations weren't enough for us, so we added HIPAA. So you can find me on Twitter at BarkerD427, and these slides are available on danbarker.codes. So we're here to talk about building pipelines. Who here uses Jenkins today? All right, awesome. Who here uses a different type of tool? Some other home-built thing? Anybody use anything home-built? Yeah. So why do we use deployment pipelines, and why are they beneficial? And when I look at an environment, I see that it can be fairly complicated. It's hard to understand the state of the system throughout the different environments. So we need to have some way of abstracting that and moving objects through the system in a consistent, repeatable manner. So this is how I view a data center. I kind of started in like running networks and building computers and stuff like that, and then became a programmer. So a lot of times I look at myself as both of these people, but I'm traditionally the dev. And so I'll create an application, and we'll have a dev version. And if this was the old world, I would have to then create a test version, send that over, have that deployed, and then have a production version. And usually when I have a problem and my code isn't working, I'll just do a yum update or run some other update system or do upgrade all of my pip dependencies or something. And so usually my dev environment is pretty up to date. Test is less up to date because I have to get a sysadmin to update it for me. And then prod just never changes unless something serious comes up, and then we'll change prod. So at some point, I am going to have to sell, or a salesperson in the company is going to have to sell a product to someone, and they're going to need access to production data and dev code because they're showing off some new feature or something. They're doing some special demo for a client, and so you end up with this new weird thing in the environment that is different than all of the others. And then we create another application, and we create another one. This one matches test because we had failures moving to test, and then we had failures moving to prod, so we create another one. And then we create another one to match our little weird box there that is for customers. And then maybe we have a Ubuntu because we acquire a company. And then we have some RHEL 6.6 version there. And as we do this, we have to start scaling up our sysadmins and our systems engineers. And of course, we will sell this and tell the client that we can get this into production within like a few weeks or something. And so now we're in this, this race to try to get everything deployed, and it's all manual, or it's all, automated, but you have to go onto every box and run a script or a set of scripts. And so as we do this, we have to start scaling up even more to maintain this, or we just start having our system suffer. So this is the way I picture the systems engineers during this process. I sit next to one, so this is what he looks like often. So this is the way I imagine an environment in the future, or something that we're moving towards, where we have a platform, and in our case, this is Kubernetes, OpenShift, that abstracts away the compute, network, and storage. So we interface with the platform to describe all of this for our applications as they get deployed. And we have at the top a deployment pipeline. that goes across the environments. And we split our environment up into a developer access area and a production controlled area. This is really a split between data and what the client has access to. So if the client has access to anything, it goes in the production controlled, because you have to assume that once a client or someone outside of your company has access to it, they will have put prod data into it, and it's now compromised, or it needs to be more protected. So the developer access side is an area where we have a lot more leniency on what developers can and can't do, and their ability to access the systems. But we do not allow any production data, and we do scan regularly to make sure that nothing actually makes it in, through some back door. And then developers don't have access into the production system. The only access is through fire call IDs, things like that. And that includes for system administrators or anybody on the infrastructure side as well. We want to treat everyone the same, where we don't have, in the current environments, a lot of times you'll have someone who has access with root and might have a long-term root access. Well, that person can also make mistakes. So we want to try to avoid those systemic flaws in our processes. So we are doing this with VMs as well as Docker containers, but I'll talk about this within the context of Docker containers because it's a little bit easier to do than with the VMs. So we have this application, it's app 1. You notice that I don't have a dev or a test or a prod version. It's Rails 7.4. So as we scale this, we are spinning up the exact same instance. So this is an identical copy as we spin up a second one. We get all the configuration from the environment, which is specified, and I'll show you in a little bit. We'll have a YAML file, and that describes everything that needs to go into the system for each different environment. And I also don't list any specific environment that's an application concern. So we have these two main areas that we've divided the data center up into. And the app teams can have, dozens of environments. They could have 2. They could technically have 1 and just deploy straight to production controlled. But that would have to go through a pipeline of testing and building and other aspects, a bunch of security checks. So we can continue to spin this up and move it into the production controlled area. And maybe there's a user acceptance and then a production environment there. And then when we deploy an app 2, all of the underlying layer is identical. And so when we push out a patch, we get that patch across all of them. If it's Rails 7.4 and there's a security vulnerability, we patch that. We get that for all of our applications across our entire company. So we don't have to go and patch each individual instance. We patch the base image, and then that base image is shared across all of our other images. And so they will automatically start to build and deploy. We put them back into the deployment pipeline of the application. We have methods for being able to override that, but we want to try to give the application teams as much power to deploy on their own without us forcing deployments. I know some companies have gone through and said, hey, we need to update everybody, and so then they update everybody, and then half of the apps are broken because there was some incompatibility they didn't know about and it wasn't fully tested. So we can spin this up the same way as we did the other one. So for these pipelines, we get to abstract audit and compliance from the app team. So we take that burden out for all of our financial and health regulations, and we can control that centrally. So we can write code that helps us stay within compliance, and that the audit team at DST likes, so that they can see all of the results for all of the different applications across the company. If you're a smaller company, I still think there's a lot of benefit here. We have thousands of developers, so at scale it becomes fairly challenging to make sure that everyone is in compliance, and the audit team has to grow exponentially. So we also, with this, we eliminate some of the trivialities, some of the wasted time. discussions about tabs and spaces. I was a spaces person forever, and I started writing Golang. Had no idea I became a tabs person until there was an analysis on GitHub that said that Golang used tabs, and I was like, oh man, who knew? So, yeah, my system, I think I was using Sublime or something like that, just automatically swapped them all out, and then when I saved it off, it changed them all back. So computers are awesome. So we also do security checks. So this allows us to do our static analysis, sending the code off and having it get inspected, doing some dynamic analysis. And we initiate this as soon as the merge request or pull request is submitted so that we can work in human time. So during that time where a human reviewer has to go and look at this, maybe pokes and prods the system, we will be running all of our checks. We know that's going to waste some, energy, some time, but we'd rather do that and have feedback to the developers faster. And when I say developers, I also mean all of our systems engineers, because they use this same process to get all of their stuff in. We actually use this for our documentation. So because a lot of times the people who want to consume your documentation will not all use the same system. So we use the same type of pipelining system to deploy all of our documentation to things like Confluence, Archer, a web page. And that way we have one source of truth, and we just deploy everything out. And as it gets updated, it deploys out to all those different systems. And we can insert tests that we want to test for at the organizational level, at the company-wide level. So this allows us to put in tests for, let's say we want to make sure that anything that writes to the file system is encrypted. Then we actually have our own internal library that enforces that and that provides the encryption and accesses the keys. And then we can check the code and make sure that there are no writes that don't use that library. So this also allows security to be a little bit more nimble. So they can create some of these higher level abstract policies, and then the pipeline will check those and add reviewers as needed. So let's say an application has added a network configuration. So now they're going to be accessing the authentication service. Well, everything should pretty much be able to access the authentication service. So when that gets checked, the policy will automatically decide that this is okay based off of policy, and it will not add anyone. However, if we want to, app 1 to access app 2, then our network security person or the group would be added on as a mandatory reviewer onto that merge request. And we use GitLab, so I'll interchange merge request and pull request. Nice and confusing. So we also use common artifact repositories. Does anybody know what I mean when I say left pad? Yeah? Okay. Awesome. Yes. I think I heard about that while I was on a treadmill at the gym, and I was like, really? People don't have all these things inside their own system? I worked at another company called Cerner where we had all of that internally, and I had lost one. I think it was a company that does configuration management, and they pulled one of their gyms, and all of a sudden all of our builds across every single instance started failing. And so, we went and found one and put it up there, but that was, we had only done the Java stuff. So LeftPad has taught me, and I think the industry, that you need to make sure that you have all of your artifacts internal. This also allows us to have one place for every team knows where all the artifacts end up. They also, this allows us to stop things from coming in that might have vulnerabilities. So, some of these tools are like Nexus or JFrog's Artifactory. And they have systems or third-party vendors who can allow you to check for security vulnerabilities. You can put thresholds on, and then you can restrict what gets in. You can whitelist or blacklist based off of these things. There's also license incompatibilities. I don't understand what that means, really. The lawyers that I've talked to don't really understand what that means. But there is somehow license incompatibilities. So you can't have certain open source licenses with other open source licenses, but they make systems for that. So I think Nexus has a plug-in system for that exact aspect. So we also gain a standardized approval system through this. So as this object, whatever that object is, goes through this pipeline, the common place to approve it is this pipeline. So we don't have 20 different approval systems, or at least the source of truth is this pipeline. It's no longer, we approve things in Archer, and this other group approves them in Jira, and this other group has written their own UI. And so when you're moving around the company, you don't get any of that benefit of scale, of economies of scale. You have to relearn as if you were joining a new company every time you switch teams. And through the system, apps become secure by default. So because we're doing all these extra scans, we are actually increasing the throughput for app teams. So the smaller change set at a faster rate is actually more secure. So teams should be able to push out changes, security patches, fixes for vulnerabilities much faster than they would have normally. So Jenkins pipelines. So does anybody here use Jenkins pipelines? All right. It's like maybe a third or half of the people who use Jenkins. I started pretty early with this in the Jenkins 1.x whatever series, and now it's baked into Jenkins 2. But there's two types of pipelines. One is scripted, very Groovy. So it uses Groovy. It's all written in Groovy. It's more powerful than the other system, so you're able to do more with it. You're able to. There are some limitations still. I found a lot of problems around. You can't loop unless the object is serializable, and so you can't loop through an array or something like that, and that makes it very challenging to build these dynamically. There's also a declarative system. So there's a little Groovy in this, but not as much. It's mostly a DSL that you follow. It's a little easier to maintain and easier to read, and it probably is a lower bar for people who don't know Groovy, don't want to learn Groovy, don't know programming. It's just an easier system. Neither of these are YAML, which is unfortunate. Some of the other systems out there use YAML instead of having any Groovy in there. So there are also shared libraries, which can be global or local. So a shared library will be a thing that you can have Jenkins use inside of another Jenkins file or pipeline. So you can write one of these. This is probably the easiest way to start as well. If you write one of these that does a simple transform on something that your company does across the entire company, then everyone can start using this. And it's pretty simple to start with. These are all written in Groovy. There are third parties who build these types of things. One is Fabricate. I'll show you some of that here in a minute. They have a bunch of stuff. They were, I think, bought or already owned by Red Hat. But they have a lot of very helpful Jenkins files and shared libraries for some of the more common tasks to help you get started much faster. And the format of these is similar if you've ever used Java, is source, var, and or the source is the same as Java, and there's also a var and a resources. So this right here is a library. So this is a global function, global library. This is, I believe, in Jenkins CI on GitHub. And it is called standardbuild.groovy. So this is defined here. It's got a call and then a body. And then it does some, this is kind of all maintenance here. And then it does this stage, which is a part of the DSL. It does checkout, and then node is also part of the DSL, as well as these. And it will go and get this Docker image that will be depicted here, and it can be called from here. So this is a Jenkins file, and see how it says standard build. So this is calling that library that we just looked at, and it just uses standard build. You give it an environment, which is Golang 1.5.0, which is something we see right here. This config.environment is that Golang 1.5.0, and now you can start building. If in this case Golang, that's a language I'm using more often, but now you can start building all of your Golang systems inside of this same common Docker image, and you can add even more to it. And so you can specify things like, well, I was going to talk about dependency management. Golang is not a good example of that. So like with Java, you can point everybody to the internal shared repository that you have. And you can do that through config that you provide in something like this. So a lot of them may be going out to Maven Central, but you want them to go to an internal Maven repository. You can provide that right here. And this is let's see. So this right here is a scripted. It's node, and then they call it node. But you see a lot of this is actual code. So there's some DSL in here, and then there is some Groovy. That try is a Groovy. That's part of the DSL. There's a catch here. And then this is the declarative. So here you have your pipeline, your agent node label. See, looks a lot cleaner. List your Maven for your image, for Docker. It's all pretty well organized. Just show the difference again. This looks much more like an actual application or a piece of software. And then this is Fabricate. So you can go to Fabricate.io on GitHub, and they have all of this there. This is the pipeline library. So this is, let's go back up here. Good, the internet's working. That was risky. So see, this is source, IO, Fabricate, very similar to the way Java would be set up. And it pulls it in. This is release and stage. It's a Jenkins file. And it pulls it in right here with this library. Very similarly to how you might pull something in with Golang. It says where it's at and then what branch. And that references this. And then this utils.groovy is pulled in right here, this def utils. So you can create one of these, and then you have this utility that can do all kinds of things for your company. So whatever the commonalities are that you can find, these common abstractions across all of your different groups, start pulling those out into this type of system, and then everyone will thank you for not having to keep that up in their own group. And then you see here this utils environment namespace. So here's the environment namespace, and it just calls this, and it's basically taking the environment and giving you back the appropriate namespace because they may not be equal for this particular Fabricate piece. So I just showed you the shared library. This is mostly built around Kubernetes. So Fabricate did some managed Kubernetes stuff along. It was kind of it's basically what OpenShift.io was. There was another acquisition in there, but OpenShift.io used to be the Fabricate components. And they had their own Jenkins. There's a lot of specialized things. So there's Java, Golang, I believe all the common languages like Node. So you can just go there, grab those, and use them as they are. Maybe swap out the Docker image for something else, or even possibly spinning up a VM. And they even have .NET. So when we looked at these, or when we were looking at Jenkins, how many people here have operated the Jenkins master? Yeah? All right. So I think you'll get this. So I hate Jenkins. It's really hard. It's really hard to keep up and running. You basically shut it down once a week and start it back up, and then you upgrade a plugin, and you have some weird memory leak. I love Jenkins. It's 10 years old. It's done a heck of a lot of good for us. But man, running it can be really challenging. So I went and looked everywhere because I wanted, if we're doing a new system, let's go look and see what else is out there. This was pretty early on in pipelines. So the pipelines in Jenkins were limited. And so I started looking around. Yeah, that was the shocked face for saying that Jenkins is awful. So Screwdriver comes from Yahoo. There's no orange juice in the Screwdriver. I also, when I heard that, I thought, Yahoo's still in business? I don't remember that. They are. So was AT&T, and they just got bought by Verizon. So I thought maybe the sale would cause some issues, but it's still being maintained. Last I checked a couple days ago, very actively. It seems like a very interesting system. It's not fully featured yet, but it's distributed, so there's a lot of different components. You can scale it up, each component independently. There's a REST API, there's a web UI, there's a launcher, and an execution engine, and then a data store. It reminds me quite a bit of a lot of these other systems like Kubernetes. And this is the diagram. So you have an API server here. You have this data store. I believe this is representing the web UI, which is really just feeding off of the API. And then you have this launcher, and you have this whole thing is the execution engine. So everything gets built in Docker containers. So very similar to the stuff we just saw, but all of this is described in YAML documents, which are a little bit easier to reason about. Although when you throw some code in there, that makes it a little bit more confusing, but there's no perfect solution. So I also looked at Concourse. This was really early on, so they had just hit 1.0. So they were also a little bit more limited. There was less documentation out there. Has anybody ever used Concourse? Yeah, a couple. Anybody use Screwdriver? I don't know anybody else other than Yahoo that's using it, but I'd really like to use it someday. It seems really cool. So Concourse has made a lot of improvements over the last year and a half. But it is an immutable architecture. It's very similar to the way Screwdriver works. It's ephemeral, so you can essentially start up the exact same task, or there's the different components are tasks, resources, jobs, and builds. So you can start up a task, and it will just repeat whatever it was supposed to do. It will not try to start up back in the middle. So you also need to make sure that, similar to the way you would do this in other systems, make sure that they're idempotent so that there are not adverse effects of having the same task do its actions a second time. And this is the architecture of that. It's pretty similar. This is a simple architecture here from Pivotal, but it's got the web UI, a database on the back end, and then a bunch of workers. And then they can pass information across these different tasks. And resources are any type of object. It could even be time, but they're generally file-based objects. And they should be versionable. So deployment pipelines have fallen behind as we were looking at this. I think some of these have come much further, but they still don't look at the holistic life cycle of an application. So all of these are still very concerned about from the time it's committed to the time it's deployed, but it doesn't necessarily describe what the entire environment looks like. So you don't get a lot of the, you have to create your own stuff around Terraform, adding in a lot of those components. There's no plugin based system really that works well at this point that you can simply add in. So we've developed something that we're hoping to open source soon. Unfortunately, we weren't able to do it before this conference. But we describe this holistically for the life cycle of the application. And basically, if you have this YAML file, then it will start creating the pipelines. It creates all the pipelines and then updates them. And if you deleted that, then your system would go away. So that would be the death of your application. So when you close down your repo, that's the end of your application, and it would be shut down. Sort of like when you deprecate a project or something. So in this we have 3 apps. They all have their own separate config. We keep this YAML config file inside of each application, and we just call it application.yaml, but you could call it anything. And we use some of the same concepts that you find in Kubernetes to manage these. But a merge request into this system will trigger an event that gets logged into Kafka, and then we have different builders that are watching this occur. And so we have one that builds the pipeline, one that builds the build config, and another one that builds the deploy. And these get put into a combined config repo. This combined config repo is a kind of staging area to move it through the different environments. But it's also how we look at what we expect the environment to look like. So we use this, we reference back to it, and we analyze the current state and make sure that what we expect is what the actual is. And if it's not, then we run whatever we need to run to get it back into expected state. So it's very similar to like Kubernetes etcd, where it's constantly checking to make sure that it is where its expected state is. So for each one of these pipelines, we have the GitLab repo that does the merge request that goes into Kafka, and then it goes into this pipeline config that gets into this combined repo, and then the pipeline config builder puts this back into another Kafka queue, and that gets to, in this case, a Jenkins deployer. But we could have a different pipeline config builder that writes something out for Concourse or something else, and then that gets into a different system, and then we have a Concourse deployer. So if we want to switch into a different system someday, we can do that, and we can run it in parallel. So we could run the exact same setup on a different system like Concourse or Screwdriver and test to see how long does it take, are there any issues, while the regular deployment pipeline moving to production isn't affected at all. So this then reads this information in and deploys it to Jenkins. We do have one thing here where we hope to maybe find a better solution for it, but we have to run this pipeline config builder first. So this Jenkins will bring in the merge request from GitLab, and then it outputs to Nexus and Splunk. And for the rest of the components, these have to happen after the Jenkins component, or whatever the pipeline component is that's really doing the orchestration. because that has to exist before any of this other stuff can actually work. So here we have the GitLab repo with a merge request. This is Kafka, and then you have the build config service, and here we have an OpenShift deployer. So this build config service is actually creating a build config, is what it's called in OpenShift. And then this deployer will send it off to OpenShift, and then we have a listener that listens for these types of events and puts it back into Kafka. So this is basically just, it's all orchestrated through Kafka and things publishing to it and then reading from it and acting on whatever messages come into that queue. And then the exact same flow happens for the deploy config. And this is similar to the other systems that you saw. We just expand it to the entire life cycle of the application. So we have some higher level concepts of stages. These were borrowed from the different systems that we looked at. Steps. So stages are the higher level things, like you might have a build stage, you might have a deploy to dev stage, and then a step inside of that might be running individual scripts or pulling down dependencies or starting up a dependency. And we have environments. So an environment in this context would be referenced. So we have what we call an environment set, and so you get some allocations. So we actually include in this the budgetary aspects of your application. So the approval for budget goes through this system as well. And we have an environment set that gets approved, and then it's usually a max limit. So you get approved for 20 CPUs and 48 gigs of RAM or something. So you can use up to that. But you can't use more unless you get additional approvals. And we will match against that and warn you that, hey, you're going to exceed that with this application deployment as you have it specified. Obviously, we don't want to kill off anybody or prevent anybody's application from running. So that's a softer limit, not really a hard limit. We don't want to ever stop an application from exceeding that unless there's something actually wrong. But we do enforce that with, that's kind of our auditing system. So we'll do automated emails and notifying supervisors, things like that. So we also have the concept of an application or document or any other type of object. We have a pipeline template and a pipeline config. And I'll show you, this is a much smaller version of the whole thing. I just took out a piece of it. But we use similar types of methods as what they use or labeling as what they use in Kubernetes. So we have a version. We have the kind as application. The name is here app1. We also have a template. So the template is providing some defaults. So as we aggregate this up into a UI so that if people don't want to work in YAML, they may want to work in a GUI, we just hide the defaults so that they don't have to concern themselves with them. I think Amy Nguyen gave a good talk earlier about UI and how that's can be an effective method of helping out your users. So we also have some notifications. We have this pipeline higher order parent there. Dependencies, so this will list what dependencies you need to have access to. And that will, this area right here is what will add on like a network security person. And then you'll have the different stages. So I said there would be maybe a build stage, a dev stage. Here's an action, and the step is deploy. And then you have the environment dev. So when we combine these two, we will get a new file that's a pipeline config. And this is what we use to then create whatever if it's a Jenkins file or if it's a YAML for Concourse. We use this to create that secondary artifact. And this will have this Maven, which came in from this pipeline template. And there are some of these variables that were overridden. So here the base image is latest, but here it's 8.0.41. And these are things that we check to make sure that it's within a limit that we want. So maybe a minor version off is the max that it can be off. And so we use these exact same two files to also create a deployment config. And this is the actual deployment config for, I guess, Kubernetes now. We use OpenShift. I think that was upstreamed into Kubernetes. But we use this, and it creates the exact document that we need. The reason we have to have an intermediary for the pipeline config is because there's no easy way to convert that over into the other system without having some sort of intermediary document. So in OpenShift, there are image streams. So this is a kind of an addition. A useful abstraction that we found is that this image stream allows you to access all of these different repositories as if they were the same one. So you don't have to do any of this more complicated management. We're trying to do the same type of thing with our VM system. We're trying to put less effort into the VM system, but we want it to be somewhat similar to how we operate in Kubernetes, so that we have a more common operating pattern. And image streams have a ton of metadata attached to them around how they were created, what type of environment variables they were created with, all the details of every layer. They can even keep versions. So with this, we can deploy like a version 18, and if it doesn't work, we can roll back immediately to version 17. In this case, it's showing version 3. But if we're deploying this out, a lot of these other systems won't keep a version of the tag latest. But this allows us to revert back very quickly. So I'll give that a second. That's a cat meme. Get it? All right. It's a groaner, right? Yeah. So we're starting to move this system over to a more Kubernetes native system, where we're using something that CoreOS created, which is operators. They created that back in December. And operators use custom resource definitions, which allow us to extend the Kubernetes API. So that application piece that you saw there will eventually be able to say kube control get applications. So this is now in beta. It uses an OODA loop, and I'll show you how this works. So with Prometheus and alert managers in Prometheus, you can say kube control get Prometheuses. We'll be able to do the same thing, kube control get pipeline configs or get pipelines. So we're in the process of moving that way. These are valuable because we don't want everyone to have to understand how to operate this thing. We'll have a core team that can do this, and then everyone else can be abstracted away from how this all works, so that they can just deploy their pipeline without knowing any of the details. So in this system, you have this cluster that's getting upgraded. You have 2 pods, and then here you have that they should be at 3.1.0, and it should have 3 members, so it does an observe, analyze, act. So it recovers 1 member, backs up the cluster, and then upgrades the whole cluster to avoid downtime. So hopefully I haven't lost anybody yet. Sorry, this is, oops. I'll have the links all here as well. So when this gets published, you'll have access to all of this. So thank you very much.